Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video we'll do another part of the past question. So in this past question we are working on this. Starts with the aid of a block diagram. Describe in not more than 4 sentences the components of a microprocessor. Okay, so the components of a microprocessor. Note that in the previous one where we did this one is a block diagram of 8085 microprocessor. That is a specific microprocessor, but for this case is that's microprocessor in general, not a particular one, but microprocessor in general. And we're given in class that this is the major component. When I say components of a microprocessor, the one that really stands out. Yes, there are other components, but basically the arithmetic logic unit, arithmetic and logic unit, control unit, and then registers. Of course, input and output device. Now let me quickly say this. In our previous video we did this. Okay, that's intruder alarm, and we said just watch the video, okay? But there's something I want to point out in that video. In the block diagram we have microprocessor, while in the simulation we did, we have Arduino there. Note the microprocessor is inside the Arduino. Okay, it's inside. I don't have network now. I would have displayed that thing again. It won't connect, but anyway, just know that. Okay, know that it's inside the Arduino. Just that what the Arduino does, the Arduino is a microcontroller. Okay, and I think we have a note on that. Yes, the difference between a microprocessor and a microcontroller, we'll get to that. Okay, and in that video we'll now show you let me just see if I can draw it quickly. We have our Arduino like this, okay, with different pins, and we have something here. Let's go closer. Okay, I don't have the diagram here. If not, I would have just done that so we all can see. But we know we have our Arduino like this. Okay, and then we gotta draw this thing very low. Okay, then we have something here, one long stuff here with different pins coming out. Okay, then we have different pin this, pin that, different pins in Arduino. Then one light, and I think lights here, a reset button here. Now this Arduino is a microcontroller, okay, and inside the microcontroller is the microprocessor. This, my friend, is a microprocessor. Okay, so the microprocessor has input and output pin. We said that before. And how do you make use of these input and output pins in a microprocessor? These pins are connected to these other pins we have in the Arduino. So it's like the Arduino serves as the extension of the microprocessor, so that we can interact with the microprocessor. By interacting with the Arduino, connecting things to the Arduino, we interact with the microprocessor. Are we seeing it now? Okay, so I think I have a slide where we did. Now you can see the microprocessor. Okay, so it's inside the microcontroller. Okay, all right, so I think that's enough for that. So let's continue with this video. So what we are going to do in this video is just to give a block diagram of the microprocessor. That's a general form which we have here already, and I've already made a video on that, so I won't dwell much on that. This is just a simple block diagram. Then for the components in it, I listed this in a video, but I didn't really give the definition and things like that, explanation. So for the arithmetic and logic unit, it's just straightforward. That's the name, that's what it means. And it is a digital circuit that carries out all arithmetic addition, subtraction, multiplication, things like that. All the arithmetic operation, also the logical operation, boolean, and, or, not, NAND, things like that. Okay, so all those things happen here. But for our control unit, this is, should I say, this is the brain of the computer, because this is responsible for coordinating operations in the microprocessor. It directs the entire operations of the microprocessor based on the instructions. Okay, so should this data go to, where should this data go to? Which register should it flow to? What should the arithmetic and logic unit, what should it do to these operands? What should they do to them? The control unit gives that order or gives that coordination. And of course, the registers are storage in the microprocessor. Some holds data, some holds address of data, and they are general purpose registers for data manipulation, and special purpose register like program counter and stack pointer for special purposes. We give more insights on that in this slide here, in this video. See, please make sure you watch all the videos in this playlist because they are all linked. Okay, so we talked about registers here. Let's look at them: general purpose register, special purpose register. We talked about them in this slide. So yeah, do well to watch that video. So then the last part of this question is the evolution of microprocessor. Okay, just to talk about the evolution of microprocessor from the first generation. Now, we've also talked about this, man. We've said a lot, we've said a lot. Oh yes, we've done that. Yeah, evolution of microprocessor, and we went a little bit deeper than we are going to do in this video. So also watch this video. I think this is the first video we uploaded in this playlist. So for the evolution of microprocessor, now they are designed in the early days basically for computational purpose. The major difference from one generation to other generation is the size. That is the data size they can process in one clock pulse, and we did that, explaining what we mean by that size here in this video. What we mean by size, we explained that in this video. 1 bit, 8 bits, we explained that in this video. So I think I'll leave a link to this video. In fact, just go through the playlist, okay, for deeper understanding. But if you want to just watch this one and get what we mean by the evolution of microprocessor, that's fine, but please watch the others for deeper understanding. Okay, so for the first generation, it's a 4-bit microprocessor. Okay, second generation, 8 bits. Are we seeing the difference now? Third, 16 bits. It's just growing like this. 2 raised to the power n, 2 raised to the power 2, 4 bits, 2 raised to the power 3, 8 bits, 2 raised to the power 4, 16 bits, and so on. That's what's happening. Can we see that? That's what's happening. So if you can have that in mind, you almost know the entire generation. Okay, at least have an idea of it. First generation 4 bits, second generation 8 bits, third 16 bits, fourth, what do you think? 32 bits, fifth 64 bits. Okay, so this is the main difference. For the other things, they are just the dates, how fast they are, and then how many instructions they can execute per second, and then just the number of transistors they are made of, and then their pins and the model available that year. Okay, so first generation 4 bits introduced in 1971 to 1972, and they had 740 kilohertz. That's the speed. Okay, 1 cycle in 1 second, but this one is 740,000 cycles in 1 second. This is fast. However, as we proceed, we see that we get more speed than that. Okay, mega. So maybe you just take a screenshot of this Okay, and then instead of me to read the whole thing, you can just take a screenshot of it if you want, and then just study through it. We wrote it down in a way whereby each generation looks like the previous generation, but with the difference in values. This one is 4-bit, this one is 8. This year is different from this year. That's just it, but we arrange them basically in the same form. Okay, so this is just it: first, second, third, fourth, and fifth. All right. So yeah, I think I'll just stop this video here, because going through each generation again will be like repetition of the previous video. To be like, because this video I did that explanation. Okay, I did, just that in this video I put it in tabular form, while in this video I just wrote them out like number 1, number 2, like that. So it's actually same content in different form, similar content. Okay, so yeah, so with that, then I'm going to stop this video here, and I'll see you in the next. Thanks for watching, and bye for now.